So there's a couple of cool ways of thinking about inverse functions. One of them is undoing the other function, and that's what we talked about in the first video. In the next video, we're going to talk about graphing these things. Graphically, what does it look like to undo a function? And there's some pretty cool results, like nice to look at, all right? But in this one, we're going to talk about a different one. And it kind of goes back to what we had before. So if f of x equals y, we can take the inverse function of both sides, right? I can say, let's look at f inverse of the left-hand side. That's going to equal f inverse of the right-hand side, right? It's a function. We can take a function of both sides, and then the white is just the left-hand side and the right-hand side. But what happens by the definition of function inverses, right? F inverse of f, these cancel each other out. We're just left with x equals f inverse of y. So notice this kind of cool relationship. Look at the first step and the last step. One of the ways that we sometimes talk about inverse functions is that the input of the regular function becomes the output of the inverse. That's going to lead to something interesting with domain and range. The domain of the regular function is the range of the inverse function. Right? Similarly, the output of the regular function is now the input of our inverse function. Right? We're going to use that a lot more in the next video as well with graphs. Let's kind of use all of this to look at example 2. Example 2 says, if f of 3 equals 2, find f inverse of 2. And there's two ways of doing this. All right. The first way of doing it is say, okay, what is the input of the first one? The input of the regular function is going to be the output of the inverse function. And likewise, the output of the regular function is the input of the inverse function. You can find that f inverse of 2 should equal positive 3. Another way you could do it is do it like we did before. Take f inverse of both sides. We can add 2 to both sides, divide by 3 to both sides, take the square root of both sides. There's all sorts of things that we can do as long as we do it to both sides of an equation. Taking the inverse function is also 1. And the reason why is because it's 1 to 1. But that's a mathematical reason for later. They essentially cancel out, and we're left with 3 is equal to f inverse of 2, which is the same exact thing that we got before. So 2 different ways of seeing our answer, showing this relationship between a function and its inverse. And later on, when we talk about graphing, I'm getting a little ahead of myself, but I'm getting a little excited. If xy, you don't necessarily have to write this down. This is the next video. xy is on the graph of f. Then y comma x is on the graph of f inverse. We're switching inputs and outputs. We're switching x's and y's. So let's go ahead and apply that with another example. Let's look. Using the table above, or table in question 37 in the book, answer the following. Find f of 0. So if you want to take really, really good notes, I'd recommend maybe pausing the video right now and copying this table down. This table that we have up here is what we're going to be using for these problems. Otherwise, it wants us to find f of 0. So again, that is our input, our x. When x is equal to 0, we're looking for what our output is equal to. All right, when x is equal to 0, what is our output, our y? So you go to our table, say, okay, x is equal to 0 right here. The output, the function value, is 8. So we say f of 0 equals 8. We've done this before. Nothing new so far. But in part B, it wants us to, it's actually also nothing new, solve f of x equals 7. And again, this can be a confusing wording for a lot of people, but it just means what value of x is, give us an output of 7. Again, this is our y. Now we're saying when y is 7, what is our x? We again go back to the table and we try to find y equals 7. Y is equal to 7 here. Okay, it's only equal to 7 right here. When y is equal to 7, what is x? X is equal to 2. All right, let's box our answers. Let's go again. Find f inverse of 7. Okay. And now we're really getting into things. So if we're looking at a table of f inverse of 7 is, again, we can think about that as a y value. And we already found this relationship, right? Inverses are all about switching x's and y's. So when y is 7, what is x? We literally just said that. X is equal to 2. So the function, if you think about a function as a machine, the inverse function is the machine that undoes the first machine. So this right over here says that when x is equal to 2, the function takes 2 to 7. Right? So what? I still have not figured out what is going on here. When x is equal to 2, the function takes 2 to 7. The inverse function takes 7 back to 2. That's what's going on here. 2 goes to 7. Inverse function takes 7 back to 2. And finally, part D, find f inverse of 1. Again, we can look at that table and say, okay, well, we don't have a table for f inverse. We only have a table for f. Well, think about that 1 as a y value. What x value gives us a y value of 1? Look at the y values. Y value of 1, y value of 1, y value of 1. There it is. The x value that gives us a y value of 1 is positive 9. That's how you can evaluate inverse functions, even if you don't know the inverse function, as long as you just have a table. In fact, this right here is exactly what we did in the last example. Right? In part C says f of 2 equals 7, so f inverse of 7 equals 2. That's what we did in C. In D, we said f of 9 equals 1, so f inverse of 1 equals 9. Let's summarize this with some harder problems. And again, these harder problems is really just about algebra. Inverse functions switch x's and y's. Switch the inputs and the outputs, the domains and the ranges. So if we look at something like example 4, find f inverse for the following functions. F of x equals x plus 5. We've already used this. How do we undo x plus 5? We subtract a 5. We already kind of know where the answer is going. But to find this, we're going to use this example to kind of illustrate and introduce a new method, okay, of finding inverse functions. So first off, write the function with x's and y's. So f of x, y, we almost always use them interchangeably. So that's our first step. The next step, we're going to switch the x's and the y's. We're going to replace the y's with x and the x's with y. And there might be multiple x's that we replace. And the next step is solve for y. How do we solve for y here? Subtract 5 from both sides. That's going to give us that x minus 5 is equal to y. Once you solve for y, replace y with f inverse of x. So we're going to get f inverse of x equals x minus 5. That's how we undo x plus 5. We just take our input and then we subtract 5. So this right here is going to be our method. This is how we find inverse functions if we have equations. Let's use this. Part B. Something more complicated, much more complicated. F of x, no, actually, hold on. Let's do the easier one first. 3x cubed plus 3. Use the step-by-step process. First, we're going to write f in terms of x's and y's. So y equals 3x cubed plus 3. Okay, that was our first step. What was step number 2? What if we numbered these? Would that be cool? 1, 2, 3, 4. Step 2, replace y's with x and x's with y's. So for the inverse function, we'll look at this. This is step 2. All right, and as a side note, this is our original function. And this is for the inverse. All right, third step was to solve for y. How do we solve for y? Well, we're going to subtract 3 from both sides. The left-hand side is now x minus 3. The right-hand side is just 3y cubed. We need to undo this 3, so we're going to divide both sides by 3. That's going to give us y cubed equals... There's 2 ways of doing this. You can write it as x minus 3 over 3. That's fine. Or you could write it as 1/3 x minus 1. If we have 2 things that are getting divided by 3, we can just divide them by 3 individually. It's your choice, which way you prefer. Both are equally correct. And now we need to take the cubed root of both sides. When we do that, we're going to get that y is equal to the cubed root of 1/3 x minus 1. And then the last step is just to write that as f inverse. So f inverse of x is the cubed root of 1/3 x minus 1. And there's some really cool relationships with function transformations here. Really cool relationships with function transformations. All right, especially if we wrote it in the other form, right? If we wrote it as the cubed root of x minus 3 divided by 3, get some cool things. What is this in function transformations? A vertical stretch of 3 and then moving it up 3. This is the inverse function, moved right 3, and then horizontal stretch of 3. Okay, so some cool stuff being done here. And actually, hold on, I mentioned it's better for the relationship. It would actually be a little different than what I said. Technically, it's moving right 1, and then a horizontal stretch by 3. But because we've already moved it right, that horizontal stretch applies to the moving right by 1. That's the thing I mentioned earlier in the function transformations video, how the order can sometimes be a little tricky. But yeah, if it's written like this, it moves it right 1 and then horizontally stretches it by 3. But there's a lot of connections here. There's a cool thing to mention, but by kind of explaining it, I maybe have overcomplicated it. We'll see it a lot in the next video, so don't worry about it so much now. In letter C, I want you to do this for a harder function. Let's see how your algebra skills are. Let's do it for this function. Step 1, write this with y's and x's. All right, this is our original function. To find the inverse function, we switch all the y's and all the x's. So this looks weird, but this is going to be our inverse function. But we do have to solve for y. So strap yourselves in. Algebra checking time. So anytime you have the variable you're solving for in the denominator, that's a problem. So we need to get out of the denominator by multiplying both sides by y minus 2. Because if we do that, well, it cancels on the right. No more variable in the denominator. On the left, let's distribute x times y minus 2 times x. On the right, we have 2y plus 1 is all that's left over. So let's get, again, we're solving for y. So let's get everything with y on the same side. Let's get everything with x. Or let's get everything with y on the same side and everything without y on the other side. So let's move this 2y over. So the left-hand side is xy minus 2y. Still has that minus 2x. Well, this doesn't have a y. We need to move this over too. Okay, let's add 2x to both sides. Now we have xy minus 2y. On the right-hand side, we have 2x plus 1. Now we're close, right? Everything on the left-hand side is a y. Everything on the right-hand side doesn't have a y, and we're trying to solve for y. But we can't just divide both sides by x. If we divide both sides by x, well, that doesn't help us for this term. We can't just divide both sides by 2 because that doesn't help us with this term. So what we're going to do is we're going to factor. Let's factor the left-hand side. Factor out a y. What's left over? Just x minus 2. And now we can get y by itself. Divide the left-hand side by x minus 2. Divide the right-hand side by x minus 2. We get some cancellation. And as long as x is not equal to 2, we're okay. And this is our inverse function. Write it as f inverse of x is 2x plus 1 divided by x minus 2. And this is true as long as x is not equal to 2. I'm not going to be requiring you to write this, so you don't have to worry about it too much. But in general, that's what's going on here because we did divide both sides by 2. And you can't divide both sides by 0. Well, we did divide both sides by x minus 2. And if x is 2, that means we're dividing both sides by 0, which is complete nonsense. So that's where this requirement comes from. Well, that's this video. Let me know if you have any questions. Good luck on the homework, and have a good day.